Hey guys, I'm making a video on downstream manufacturing. So I work for different companies and worked on different molecules, mostly biologics. So um, like mAb products, enzymes. So in this video, over the years, I have made some notes on over 20 products. So in this video, we're gonna go through what type of manufacturing issues that we encounter during run support and as a process engineer, and basically give you more in depth of different chromatography and different column sizes, different loading conditions, buffers, and viral filtration, GFDF, basically the whole downstream section, downstream area of a biological drug substance manufacturing. So the first molecule that I have is can't name the molecule due to privacy reason, but it's a Pro A, 45 centimeter diameter and 25 centimeter height, 5 cycles, 60 MMAs, mixed mode, and this is mixed mode chromatography, so it's hydrophobic and anion exchange. Um, so we're gonna go into more detail of this. So they use anion exchange ligand and also the hydrophobic properties resin combined. So So the ligand interact with protein using both mechanisms to separate target products and impurities. And then the separation is controlled by operating pH, conductivity, and temperature. So this one is very interesting. And then they also have purely hydrophobic. So the hydrophobic ligands bind strongly to mAb at high ammonium sulfate concentration and weakly to mAb at low ammonium sulfate concentration. And then you have inline conditioning that is used to increase lowered ammonium sulfate concentration, gradient used to decrease ammonium sulfate concentration and separate impurities. So now on to protein A, and so the protein A starts with equilibration phase, pre-column. So the it has to have uh like condition. Um, it has to have conductivity similar to load. So similar conductivity, and I'm gonna write it down here. Similar conductivity as load, and then the UV signal is close to zero. Neutral pH. Um, Neutral pH. Um, so basically, you're preparing your column for loading. So prepare column for loading. Then you have load. So the product binds to resin at neutral pH. Uh, and then you have increased UV signal primarily um, because UV absorbs media component. So that's a point. Increased uh, UV signal due to UV absorbing media components. Then you have a wash step, and then so the thing is that as soon as so this is important. So as soon as you finish your loading, your signal during wash one, the UV signal uh, returns to zero within certain CVs. Uh, so let me draw it out here. You have this, and then you have the I'm interested in the UV signal. So let me draw it. So during loading, the UV signal is like this, and then it comes back down like that, and then this is the start of wash one. Sorry about this. And then you have um, wash one, so the conductivity remains low, and then you have wash two, wash three, and then you have your elution phase, so the conductivity goes up, and then it comes like this, and this is expected. So this is A280, and so it comes back down during elution, and then this is a strip. Your A300 is like this. It goes like this. It comes back like this, and as you know, it goes like something like this and that. This is your uh, A300 UV, and your conductivity.